Hi, this is Jim Thompson, returning for another session in my Unity programming for the Oculus Go series. So where we left off last time was we had this really simple scene just with an OVR camera rig, a ground surface, a plane, and a cube, and I just did a test build on it just to make sure that the build settings were okay. So we did a test build, and at the end of the last video, there's just a few seconds of just me testing out to see that the scene is loading and running and visible through the Oculus Go. So we want to continue on today, entering into the realm of programming for the Oculus Go. And so basically all I've did a little bit ahead of time. I made an empty game object, create empty, and I named that empty game object a player events object. And I did add component, new script, and I named the script player events. And if I edit that script, it's going to open up for me in Visual Studio, ready for me to have a look at. Okay, so I'm just going to switch back to Unity before we dug into the programming. What you'll find if you look at my YouTube playlist is that there's a series of tutorial videos that I didn't do. For Andrew is his playlist name. He's basically created a system that I'm using and implementing and expanding on. But he has a whole series of videos dedicated to VR control systems in particular, which are really good. Check out my playlist for links to those. So I'm using his system, but expanding on it and kind of tweaking it for the Go, just so you know. Okay, so I'm going to my player events object, going to the script, and I'm going to edit script, which I've already done, and it's opened up in Visual Studio. And so here it is. Here's player events. Okay, so the purpose of this script is for us to make a connection to the Unity event system, and through that event system, connect with Oculus's integration system in order to access the controls on the controller, to access the trigger. So when we pull the trigger, we want it to do something, it'll do it. If we hit the touchpad in a certain way, it's going to do what we want it to do, etc. So that's what the purpose of this script is. It's to make that connection. So we're using the Unity event system. So we have to add that in under the using so we can get access to that library. So just Unity engine.events. And it's grayed out right now because there's nothing in our code that's actually accessing it yet. Okay. And now we're going to continue on into the class public player events, and we're going to expand, create some regions for variables that we're creating there. And I liked how Andrew did this. He's creating using region, and basically he's creating a set of variables for particular areas of the script and identifying them under this region. And that basically lets us see groupings and minimize groupings of variables. And it just looks nicely organized. Okay, so I'm creating the first of the variables here. And so we're going to be pulling in the class of Unity Engine events that allows us to create new actions and to access all the stuff that the OVR input system has into it. I'm making them static, and that makes them a global variable, which means that we can access this particular variable from any script in our system that we're creating at any time. So public static, global variable, accessible throughout our application. You have to understand that when you're targeting this on touchpad up, on a script, it's accessing on touchpad up from this particular script. If you change the name of an action and you don't change it on another script, you're going to have issues. So just remember the names that you're giving things. We're creating it as a null right now, and then we're going to give it a value later on. What we're doing is we're creating a delegate system. We're creating this static Unity action, and then we're going to basically tell our application what that action is later on in the pointer script. So again, doing another public action, Unity action, and this one, strangely enough, is on touchpad down. Fancy that. So basically, if we've clicked and released the touchpad button, or if the button is down. Another static Unity action on trigger pull. So we're declaring them as nulls all along. And then we're going to, in our code, we're going to be adding in what we actually want to have happen. Okay, so now what we're doing is we're creating another Unity action that's pulling in from the Oculus input, the Oculus integration that we imported into the scene. So if I say OVR input, it's now looking at all the scripting that we brought in with that Oculus integration. It's finding OVR input, and what we're doing is we're setting up a controller, and we're setting up a controller source. So the next section that we're creating is a section for the anchors, and these correspond to sub-objects in the OVR camera rig, corresponding to the left controller anchor, the right controller anchor, and it's identified as the head anchor here, and that's the center eye anchor in the list in the OVR camera rig. Basically, we need to identify for our scripting the object that's the left-hand controller when it's in use, the object for the right-hand controller when it's in use, and we need to know where the main camera is in our scene. And so that's what the head anchor is. And I'm actually going to use that. We're going to be creating a gaze camera as well. So we need to know where the head anchor is located and where it's pointing in order to do a gaze anchor. So that's the section, the region for anchors is for that. For the different cameras, and then we need the last region here for the actual inputs that we're going to be using. Okay, for us to access all of the different controls that are available to us, we have to set up a system for OVR input to check what controller sets are available to us. So what we have to do is set up a controller sets variable, And that's basically going to allow us to search for and check which controllers are available and which controllers are active. And again, I'm just initializing them as nulls, and we'll be creating them, giving them some values later on. So I'm just declaring input source and declaring a controller. And again, so basically we're initializing these as none, and then we're giving them a value as basically when the script starts running in the application on the headset, it's going to check what controller is active and whether we're getting input from that device. And if we are, then it's going to work, and if it isn't, then we're in trouble. And when we're in trouble, if it can't find the controller or an input, that's what this last item is all about. Private bool m input active equals true. When it isn't true, then basically we just want to stop everything from trying to work. Okay, so let's just review what we've got so far. So we've set up events. So I've got a public static on touchpad up, got touchpad down, got trigger pull, got trigger release. And those are the four main actions that you've got. There is that secondary button. I'm leaving that out of my inputs events for now. We may later on decide to do that, but I think if I show you these, you'll kind of get the idea. And if you really want to use that button for something, you can. It'll be fairly obvious how you would set it up. Okay, so I don't really need a void start on this script, but I would like to set some values as soon as this script is loaded into the scene, and it's loaded into the scene right away at the beginning, as soon as our app starts running. Okay, so we get some nice value by using that OVR input module that we could download from the asset store. So under OVR Manager is a class that's available through that system, and part of that system is the headset mounted on your head. Okay, so as we continue on in the series, one thing you have to realize is we're developing a programming system that as we develop it, you're going to end up seeing some parts of your script underlined in red as errors until we actually get those items created as part of our code. So, for example, in this void awake, I have OVR manager .htmd mounted plus equals. So I'm creating a delegate called player found, and in the next line I'm creating another delegate player lost. So I'm saying I'm going to add those delegates in, but they don't exist yet. So they're underlined in red because they haven't been created yet. You have to start somewhere. So in my errors here, it's telling me it doesn't exist, and yeah, they're absolutely correct, it doesn't exist. Later on, we will create them though. Okay, when we create a delegate, we're adding functionality into this HMD mounted. If this particular script is no longer in use, if the object is destroyed, or if we pause the game or whatever, we don't want our system to still be using player found and player lost. We want the connection to the delegate to be broken at that time. So what we want to do basically is we've done a void awake. I'm going to designate it as private. And then we also want a private void on destroy. And basically we just want to do the opposite. So rather than typing them, I'm just going to copy and paste, but I have to make sure that I do minus equals. Okay. So base HMD headset, if our Oculus Go is on our head, player is going to be found. And if we take the headset off, it's no longer senses that we have mounted the headset. It's going to be unmounted, it will be player lost. And those checks for whether the headset is on or off, those will only run as long as our application is running. We are using void update, but I'm just going to designate it as private. And here, this is now where we're checking whether input is active, check for a controller, check for an input source. And again, as I create these, they're going to show up underscored in red because we haven't created them yet. But we will be creating them. Okay, so what I'm saying right here is if we aren't getting any input, just stop. No point in going on if we're not getting any input. And then I'm checking if a controller exists. And so this is an instance where check for controller doesn't exist anymore, or it doesn't exist yet. Going to check for an input source. And if there is some input, we're going to run it. Okay, so lots of stuff underlined in red. No problem. We'll catch it later. So right now, we'll start taking care of business in some of these. So I'm going to start by doing the check for control. Okay, so remember that we've declared up at the top under region input, we've declared basically that there is going to be a controller, but we initialized it as none. So when the script first reads our variables, there is no controller. So we'll check whether the left remote is active. And again, all of these items, they come in as part of the OVR input. So that's why when we're setting up our system, setting up our project, we needed to bring that in as part of the items we needed in order for our project to run properly. Okay, so we are going to check, is the controller connected? What controller? The left tracked remote. And if it is connected, our active controller system basically is that left track remote. And we've got a right remote. And basically it's the same. So let's copy and paste. But where it says L, it needs to be R. So for the left remote and the right remote, we're just checking, is that controller connected? So our active controller is from controller check And again, it's looking, just like we've got some other, we still have these functions or delegates that haven't been created. They're still underlined in red. Update source does not exist at the moment, so it's showing as underscored red. So basically, eventually, you have to create this in order for the system to work. Okay, so that's as far as we can get with check for controller. Continuing on, we're going to do check input sources. So again, all of these are private voids. They don't need to be accessed from other scripts. Yeah, so what we're doing here is we're updating the active controller. Okay, so again, we haven't created update source yet, so it's underlined in red, but we're going to get it by running a built-in function that's part of the OVR input system, that Oculus integration package that we brought in. That's where we're getting this, and it's checking what controller is active in the scene. And it could be the left controller, If we're on the go and we've selected our controller to be the left hand, it's going to be our left hand controller. On the headset, if we selected the right controller, it's going to be right. So that allows us to switch hands on the controller, by personal choice. Okay, so we want to start creating the inputs for the different actions that could happen on that Oculus Go controller. Okay, so first thing we're going to do is check, has the touchpad button been pressed? So it's OVR input get down. And so which button has been pressed? What do we want to get the input from? So OVR input button, primary touchpad. So for the Oculus Go, primary touchpad is that main touchpad button at the top of the controller that we're normally touching with our thumb. So what do we want to do? Okay, you have to watch your capitalization. So these are built in. So if I capitalize the pad and touchpad, I get an error. So as you're creating these scripts, just remember and keep an eye out for that. That's an easy bug to introduce into your system here. Okay, so that takes care of the primary touchpad having pressed the, okay. Touchpad up. And basically it's the same. So I'm just going to copy and I'm going to paste, but it will be get up instead of get down. And here it's on touchpad up and on touchpad up. So this one runs when the button's been pressed. This one runs when the button's been released, but it's not running anything yet because we haven't made an on touchpad up or down yet. We've declared them up at the top, so that's why they're not showing with a red underline. We declared the action up at the top, but we've initialized it as null. So until we actually create something to be that input, nothing's going to happen. And similar kind of setup. Okay, so if OVR input get button or get down, OVR input button primary index trigger. So basically what that's doing is it's creating, it's treating the trigger like a button. So if you've basically pulled that trigger at all, it's going to do the action that you tell it to do. It's the same idea. If it has happened, and if not, nothing's going to happen. up my mistake. So it's get up for the trigger release. Okay, so let's just go over the input. So if we're getting input from the controller, so this runs, if you scroll up again, so this is happening every time the game plays a frame. If it isn't receiving any input, it's just not going to run. It's going to check for controller. It's going to check input source. And then it's going to run the input. So we've created those. Haven't done update source yet. But those are now have some functionality in them. And it's all based on what are the actions that you want to do. So if you wanted to have something for that other button, I believe it's assigned as button 2. Button 1 being the touchpad. Okay, so that's something we should check. All right, so how can we check that? Okay, so I'm just going to pause the video for a sec, and we're going to go on the net, and I'm going to show you. So I have gone to the website developer.oculus.com, and in that site, if you look at the table of contents on the left, under the develop section, Oculus documentation, there's a Unity section, and it's not the only way that you can program for the Oculus Go. There is an Oculus Go native SDK that does not use the Unity engine. I'm not going there. So Oculus Unity, looking at the developer guide, and looking at the Oculus utilities. Okay, so there's basically, this is an explanation of what we did when we downloaded the utilities plugin. Gotta say, it's not all that useful. It shows you a little screen capture of the components. Doesn't really tell you an awful lot about how to integrate them into the system. I'm just going to go over to the OVR input section, and I'm going to look at the Oculus Go input handling just to show you. So my personal feeling is, man, they could have made this site a lot more useful, but just by showing a few examples, just like I am showing you here. But anyway, here's the inputs that are available to you from the Oculus Go. We can get an axis 2D from the primary touchpad. So that basically means an XY grid of our location of where we're touching it. And, get a click from that touchpad, and we can get a touch on the touchpad. And it's considered to be button 1. So if we're clicking it, it's considered to be button 1. There's a button for the primary index trigger. You can't see it, but it's there. It's basically, if you pull it back at all, you're clicking the button. And there's the button dot back or button dot to. That's the arrow button. Oculus button you cannot program for. And there's some raw mappings as well that I'm not going to get into, other than like that's if you wanted to do something that changed depending on how much you were squeezing the trigger, you would be looking at the raw rather than treating it like a button. Okay, so that's just a quick glance at it. So if you wanted to add in an input for the other button, you could name it, say, on button 2 down or on button 2 up, and declare it as null, and you could go through the same kind of setup, creating some kind of a delegate function that you can call. Still, there is still no particular action assigned to that delegate yet. That's something we're going to do on our pointer script. Okay, so the last thing that we need to do on function is to get rid of the other items that are still underlined in red. Okay, so we want our headset to check whether it has been mounted on your head or not. And we also want it to update our source to make sure that we're using the controller that is active. Okay, so last couple of private functions here. So I'm doing private OVR input controller update. Sorry, didn't see that come up. Okay, private OVR controller update source. No, and I put that in the wrong spot. I need to cut that because that's supposed to come in after the ending of that private void input. So sorry about that. Okay, so when this function runs, it's going to give us the name of the controller that is in use. It's storing it as previous, and then the next time it runs, if it will check for the controller again, and if the current one that it finds is the same as the previous one, it does nothing. Just in any case, we want it to find the current controller, so get controller object, and it's returning that value. So that's why it's private OVR input controller rather than private void, for example. Void means it's not returning any kind of value. Here we want it to tell us what controller is in use. So get controller object, game object, controller object equals null. So I'm declaring a local variable controller object, setting it to null initially. Okay, and controller sets is underlined in red because we don't have that set yet. Okay, so if there's no controller set, we want it to set our controller object as our headset. Not that we can get any input from the headset, but basically it'll just default to not having a controller. So if we're getting input from some kind of controller, set its value to whatever the current controller is. And so whether it's the previous one or the new controller source, we want to return the value of what it got. Object. Check. Okay, so we're getting there. Okay, so just the last couple items here. So basically, if the headset is on, we want our input active to be true. And if the player is lost, we want our input active to be false. Okay, so scrolling up, player found and player lost are no longer empty. And last one, we need to create controller sets. So basically we need to make a list. And it's going to be a list of game objects. And that list is going to be named, it's going to be pulled from create controller sets. Okay, so we're going to run that. So basically, I'm adding items onto the list. So what are the possible controllers that there could be? So OVR input controller dot L track remote. And the right track remote. Although it's not really functional, you could also say a touchpad on the head anchor. Okay, now if you're doing input for a Samsung Gear, there's a button on the headset. We're using Go, so can't do it. So there's our set of available controllers. Where we're touching it. We can get a click from that touchpad, and we can get a touch on the touchpad, and it's considered to be button 1. So if we're clicking it, it's considered to be button 1. There's a button for the primary index trigger. You can't see it, but it's there. It's basically, if you pull it back at all, you're clicking the button. And there's the button dot back or button dot to. That's the arrow button. Oculus button you cannot program for. And there's some raw mappings as well, what I'm not going to get into, other than like that's if you wanted to do something that changed depending on how much you were squeezing the trigger, you would be looking at the raw rather than treating it like a button. Okay, so that's just a quick glance at it. So if you wanted to add in an input for the other button, you could name it, say, on button 2 down or on button 2 up, and declare it as null, and you could go through the same kind of setup, creating some kind of a delegate function that you can call. There is still no particular action assigned to that delegate yet. That's something we're going to do on our pointer script. Okay, so the last thing that we need to do on this function is to get rid of the other items that are still underlined in red. Okay, so we want our headset to check whether it has been mounted on your head or not. And we also want it to update the source, update our source to make sure that we're using the controller that is active. Okay, so last couple of private functions here. Okay. So I'm doing private OVR input controller update. Oh, sorry, didn't see that come up. Okay, private OVR controller, update source. No, and I put that in the wrong spot. I need to cut that because that's supposed to come in after the ending of that private void input. So sorry about that. Private OVR input controller. Okay. Okay, so when this function runs, it's going to give us the name of the controller that is in use. It's storing it as previous, and then the next time it runs, if it will check for the controller again, and if the current one that it finds is the same as the previous one, it does nothing, just returns. In any case, we want it to find the current controller, so get controller object, and it's returning that value. So that's why it's private OVR input controller rather than private void, for example. Void means it's not returning any kind of value. Here we want it to tell us what controller is in use. So get controller object, game object, controller object equals null. So I'm declaring a local variable controller object, setting it to null initially. Okay, and controller sets is underlined in red because we don't have that set yet. Okay, so if there's no controller set, we want it to set our controller object as our headset. Not that we can get any input from the headset, but basically it'll just default to not having a controller. So if we're getting input from some kind of controller, set its value to whatever the current controller is. And so whether it's the previous one or the new controller source, we want to return the value of what it got. Check. Okay, so we're getting there. Okay, so just the last couple items here. So basically, if the headset is on, we want our input active to be true. And if the player is lost, we want our input active to be false. Okay, so scrolling up, player found and player lost are no longer empty. And last one, we need to create controller sets. So basically we need to make a list. And it's going to be a list of game objects. And that list is going to be named pulled from create controller sets. Okay, so we're going to run that. So basically I'm adding items onto the list. So what are the possible controllers that there could be? So OVR input controller dot L track remote. And the right track remote. And although it's not really functional, you could also say a touchpad on the head anchor. Okay, now if you're doing input for a Samsung Gear, there's a button on the headset. We're using Go, so can't do it. So there's our set of available controllers. So final steps in our process for setting up the player events. Just going to run through the script one more time. So we're setting up a connection through the scripting, setting up a Unity action based on each of the things that we can do on the Oculus Go controller, on touchpad up, on touchpad down, on trigger pull, on trigger release. We're setting up an anchor for the left controller and the right controller, and we're setting up an anchor for where the headset is. We're going to have an input source based on a controller and a controller object based on the controller, and we're going to be checking whether the input is active or not. When this script starts running, basically as soon as the app starts running, it's going to check whether the headset is on our head or not. If it is, our inputs and everything's going to be entered and all of that. If it's not, basically, it just basically does nothing, doesn't run. When this script stops running, delegate checking whether the head is mounted or not stops running. It's removed from our function. Every frame, it's going to check whether there's any input, and if not, it's just going to return, and that's it. And basically what would happen is the head, if there is no input coming from the controller, if there is no controller, the Oculus Go headset would tell us there's no active controller. Our app is going to check for the controller. Our app is going to check for the input source. Our app is going to run any input there is, and all of this is happening like somewhere between 30 and 60 frames per second, we hope. The controller checks whether it's the left remote that we're using or the right remote that we're using, and it lets us know which one we're using. And the M controller gets assigned as the controller that it finds. Private voice check input source, and it's checking what controller is active so that we are getting our input from that same controller. the input itself, we're setting it up. If input, get down OVR input button primary touchpad. So if we click on the primary touchpad, if it has not already received input, then we're going to run it. Same with button up on that touchpad. Same with the trigger pull and trigger release. It runs update source. So if you look at the update, it's running these functions every frame, and part of those functions are checking the source. And basically, so every frame it's checking, is the controller that's active the same one as before? If it is, then it returns. If it isn't, then it returns what the controller is. The function player found basically tells us, is our input active or not? So if the headset is on, yes, we're going to receive input. If the headset is not, input is false. And if you look at the private void update, so every frame it checks if it's receiving input. If that is true, it's going to do the rest. If it's not true, then it's going to return. And the final function in the list is basically listing the available controllers. So it's creating a controller set, and the controller sets available to us are the left remote and the right remote. And then I've put in an OVR input for a touchpad on the headset. We don't have one, so I'm commenting that out. But if you say you were building for Samsung Gear, you could use that. I am actually going to be using the head anchor to do a gaze pointer, so I don't want that to be treated as an input. I'm dealing with that separately. Okay, and that's it in the programming. So if I save it and I go back to Unity, on player events, we have a left anchor, a right anchor, and a head anchor. And if I open up OVR camera rig, open up the tracking space, we have left hand anchor, and inside that is left controller anchor. We have right hand anchor, and inside that is right controller anchor. So I'm putting left controller anchor under left anchor, right controller anchor under right anchor, and I'm putting center eye anchor as the head anchor. Okay, and I'm going to save that. And basically what that gives us is the ability through our scripting to get input from the controller. If I look at the scene, it doesn't change the visuals in the scene at all. It doesn't change our capabilities in the scene right now. That comes in the next script that we're going to do in creating the pointer. One thing we can do though for now is on the right controller anchor, what I want to do is add in a visible model for the Oculus Go controller. So easiest way to do it is just to use the search button and just go Oculus Go, and you'll find a little prefab model of the Oculus Go controller. And I'm just going to drag and drop that onto the right controller anchor, just so that when we do a test build on this, we'll see that. Okay. Now, a smart thing to do when you're doing a scripting like this is, number one, just run the scene. Hit play, let it run, and any basic errors in the script are going to show up in the console. So I don't have any errors. It's cautioning me, though, that the headset isn't actually connected and running, so there is no input coming into the scene, but it does run without any script errors. So it gives you a fast way of finding just basic typos and that kind of thing. Okay, and I'm going to do an Oculus build and run but I'm not going to do it at this point. So we'll say that's it for the video at this point, and I'll pop back and we'll do a build. Okay, bye for now.